This is the video going over the chapter 10, 11 multiple choice review. Okay. So for number 1, we're checking our 3 conditions. So the randomness condition has not been met. She just went to the store and took the next 30 customers in the line. So this is random as a no-go. She does have less than 10% of the population. There's likely more than 300 people that go through that grocery store. And she has a big enough sample size of 30, just barely big enough for normality for the central limit theorem to kick in. So B is the answer. Randomness was the problem there. So for 2, biologist wants to estimate the average weight of dolphins. So this is going to be an interval because we're estimating a number. We only have one population. Let's see our options here. So we know it's going to be a one sample situation. There's no pairs to be had, and there's not a second sample. We know that when we're doing means, it should be T, and so not proportion. You don't have a percentage of dolphins, you have a certain number of dolphins. So now we're down to A and B, and keep in mind the interval is trying to estimate the population mean, not the sample mean. We want mu, not X bar. So the answer is A. For number 3, so I wrote out the ho and the ha there, and 92.23 is our X bar. So we want to know what the p-value means. Okay, so when you interpret the p-value, there's a very important first sentence. It's assuming the ho is true. It's the probability of getting your sample, or even more extreme than your sample. So those first 3 ones are missing that important first sentence of assuming the ho is true. So if the mean amount of money is $100, if the ho is true, remember this is the ho, 0.026 is a probability that a randomly selected group of 32 students would spend a mean of 92.23 or less than the recent first dates. And E does have an attempt at saying if the ho were true, but it's not actually saying the ho. The E is saying if the ha were true, because that's the one that's less than. We want if the ho is true. We assume the ho is true in the beginning, and you assume it's true until you prove otherwise. And another thing to keep in mind, if we were to have our sampling distribution, we need to center it around 100, and we're finding this p-value. Where are we? Less than 1, so we're down here. So this p-value is this area here, right? That shaded area. So that's assuming that your normal distribution or your t-distribution is centered around the null value. Okay, number 4. Half the battle here is just reading through the paragraph with a whole bunch of numbers and pulling out what is the ho and the ha and what do the different numbers mean. So I did that. I have written out the ho and the ha and what all the values are. Here's my equation, my t score equation. Now keep in mind, we assume the ho is true until proven otherwise. So here's the ho, right? Now if I subtract mu c from both sides, I get mu d minus mu c equals 0. So really what I'm saying is this guy equals 0. So in their equations, they did not bother saying minus 0 because minus 0 doesn't change the math at all. So all they really have is the x bar d minus x bar c, and then they didn't bother saying minus 0. For 5, let's see. So remembering that the hypotheses are always about populations, not about samples. There's no guessing to be had about samples. The samples are a fact. We have those numbers. What we're guessing about is what's going on in the full population. So the ho and the ha should always have mu and not x bar. So that eliminates A and B. And then it comes down to just reading in the paragraph what the direction of the ha should be. And they said the mean length is greater than 9.5. So we want greater. So it's C. For number 6, so this is getting into specific ways to describe a confidence interval. And in general, especially when you're writing it in a free response and you're using your own words, just always use the sentence stem because it's very easy to say something wrong. Just use the sentence stem. Okay, so some things. A is not right because we don't know that exactly 95% of the children will be in that interval, 95% of the children in the population. We are kind of guessing that. We're saying it's about that, but we don't know that it's exactly 95%. For B and C, we don't ever want to talk about probability because it's not a probability issue. Probability is about something that's like in the future that hasn't happened yet, and you are trying to make guesses about what's likely or not likely to happen. Like there's a 50-50 chance of getting heads if you flip a coin. Well, that coin hasn't been flipped yet. It's a thing in the future. Once you flip that coin and you get heads or tails, it's not probability anymore. It's just a fact. And even if you flip the coin and don't look at it, so you don't know if it's heads or tails, the fact that you don't know it doesn't make it not a fact. The coin was in fact heads or it was tails. So the confidence interval is trying to estimate a number that does exist. It is a real factual number. We just don't know it yet. So it's not a probability issue. It's a different issue. It's a confidence issue. So avoid probability words. Probability would be bad. Chance would be bad. So just use the sentence stem we're used to. We are 95% confident. That's the better word. And then the difference between D and E is, again, we're making let's not use the word hypothesis, but we're making a guess. We're making an estimate about the population. So in the program, talks about the population. In the sample, is not about the population. It's about the particular sample. Okay, so for 7, so 7A is only talking about the sample. It's a true fact, but that is talking about the difference between the two samples. It's not describing anything about the population beyond those particular samples we have. B is a little bit hard to understand because your intuition is like, well, there was more positive values and negative values. So it makes you feel like maybe that's more likely. Long story short, it's just not that simple. That involves much bigger probabilities. All the values in the confidence interval are not equally likely, and it just gets very complicated trying to make statements like that. So at this level in this class, we just say numbers that are inside the interval are plausible. That's our favorite word, plausible. And the numbers outside the interval are not plausible. So just stick with that. That is kind of the level of math that we have tackled around that issue. So B is making statements that we just don't know are true. It's more complicated than you think. C was just dumb. I don't know. That's just not true. I mean, they are different. Anyway, D, the values were differences. So it's something minus something. And if it ends up being a smaller number minus a bigger number, you get a negative. So negatives are possible. So E is the important thing. 0 is almost always a really important number when we're talking about comparing two things or talking about differences. So because 0 is in there, some of our plausible values have cherry fizz being bigger. Some of our plausible values have, what's the other one? Cherry eclipse being bigger. And we have one plausible value of 0. That means there's no difference. So we can say it's possible. It's plausible that there's no difference. That's all we know. So for number 8, again, I wrote out the ho and the ha based on the paragraph. Notice that the p-value is bigger than alpha. So p is big. P is not low. So we do not reject the ho. So we do not reject the ho. We stay with the ho. We have failed to find, and remember that in our conclusions, it's just like how in a court system, people are either guilty or not guilty. Not guilty doesn't mean innocent. It just means a prosecutor has failed to find evidence to prove them guilty. So it means really we don't know. We failed to find evidence. And that's all we need to let someone go, because we assume that someone is not guilty we assume someone is innocent until proven guilty. They failed to prove them guilty, so we fall back on saying, we don't actually know that they're innocent, but we know they're not guilty, so they're not guilty. Same thing here. So She failed to find evidence to move away from the hoe. We don't know that the hoe is true, but she failed to find evidence. She does not have convincing evidence to conclude that the ha is true. And the ha was that they were different. So there's our keyword. Not equal to, not greater than. Okay, that's it, I think.